A ladder 15 meters long leans against the wall. The ladder slides down the wall, so slides down the wall at the rate of 1.5 meters per second. What is the rate of change of the angle at the ground when the ladder is 6 meters from the wall? Okay, so this is the direction when it's at the sliding down. This is our ground, X, and it's sliding down the ladder. This is our ladder, this one, okay, 15 meters, and it's sliding down at the rate of 1.5 meter per second. As it's sliding down, the angle is changing, right? So we need to find change of angle when the ladder is 6 meters away from the wall. So this one, 6 meters. Okay? When it's 6 meters away from the wall. Okay. So we need to find d theta by dt. Our wall here is a mathematical way to represent. So it's y, and x is gonna be our 6 meters, and 15 it's gonna be the length of our ladder. Okay, so first thing, what we are going to do. So because our angle is gonna change as the ladder goes down, we mark down as a dq, d theta by dt. Okay, d theta by dt, and y by dt, because as time goes by, its angle is changing, and this is our question mark. This is what we need to find out. And this is, we need to find the change of angle when x is equal 6, at the point of x is equal 6. Also, we know that x is changing 1.5 meters per second as the ladder is sliding down. So its change, it's a derivative, right? dx by dt is equal 1.5. When something is in the situation of changing, that's a derivative. If it would stand like here, we want at the point of 6 meters, it's just x is equal 6. But angle is changing, it's derivative. It's measuring rate of change. X is changing, it's derivative because it's changing a rate of change of distance. Okay, so, and we are going to use these values when we calculate. All right, so first thing, we are going to pay attention that our triangle is with the right angle, right? Because the wall creates at the right angle with the ground. Nobody built the wall under the angle, unless it's a lousy builder. Hopefully we never meet like that, anybody like this. All right, so because we have triangle with the right angle, then the cosine, or I can find cosine or sine of theta. Let's take, for example, cosine theta, because we have change of dx by dt. X is, we are given x, therefore would be easier to find cosine, which is adjacent. So cosine theta, it's going to be equal x over 10. Adjacent leg, this is adjacent leg. Okay, let me write down here where adjacent leg to hypotenuse. Adjacent leg, and this one is hypotenuse. The side against of right angle is, we call hypotenuse. So it's going to be, oops, x over 15. Okay, so this is the key relationship that we will allow us to complete our solution. This is very important to know that cosine theta is x over 15. Since we have change of theta, we need to find change of theta, change of angle, d theta by dt, and we have change of x. To be able to connect with each other, change of angle that is directly connected to change of the x, then we are going to take derivative where d by dt cosine theta is equal d by dt x over 15. Okay, from here we are getting derivative of cosine theta is going to be negative sine theta, and derivative of theta itself, because we don't know if it's we need chain rule or we don't need it. Maybe theta can be expression. So therefore we write down this way, and it's equal 1 over 15 is constant, comes out, and we are having under derivative our x, so dx by dt. Okay, so next we are going to figure out our dq, because this is our goal, right? Here it is, dq by dt. So from here, dq by dt is going to be equal negative 1 over sine theta times 1 over 15 and dx by dt. So we're practically taking this part and dividing by this part. That's it. All right. So to complete this solution, because this is our solution, we need to know the value of sine theta at the moment when x is equal 6 meters. So we need to find how much is our sine theta, right? Because we have dx, correct? Here it is, our dx is equal 1.5. So all we need to do is find our sine theta to be able to find the change of theta itself, right? Okay, so how I'm going to find out? First of all, I'm going to use this triangle with the right angle to write down Pythagorean theorem. Pythagorean theorem says, let me see, this is opposite leg. Pythagorean theorem says the sum of squared legs is equal the hypotenuse squared, which is, we are going to have here x squared plus y squared is equal 15 squared. So from here x is given 6, so 6 squared plus y squared is equal 15 squared, and we are getting y squared is equal 15 squared is 225 minus 36. It's going to be how much? Y squared is equal 15 minus 6 is 9, 11 minus 3 is 8, and we are getting 189. Hence, the y is going to be equal 13.75. Okay, so from here, so sine theta sine theta is equal y opposite leg over hypotenuse over 15, which means 13.75 over 15, right? And we are getting, let's round it up to make it easy. I'm going to round it up and get 14. Otherwise, it's going to be nightmare to go like that. 14. Numbers are not given good unless I did somewhere silly mistake, but I don't see how I could make some silly mistakes. Okay, so I'm going to round it up, get 14 over 15 to easy, with the purpose easy to solve. Okay, so once we have it, we are going to finish this solution, and we are getting d theta over dt is equal, so we have negative 1 over sine theta, I'm rewriting so I can plug the numbers, times 1 over 15 dx by dt. Okay, and we have from here is equal d theta by dt is equal negative 1 over sine theta. So if sine theta 14 over 15, then 1 over sine theta, it's going to flip, right? I will get 15 over 14, correct? 15 over 14, and then times 1 over 15, and our dx by dt was how much? 1.5. Well, okay, if our dx by dt 1.5, then maybe might as well this 1375, well, maybe we need to convert everything into, no, let's do it mixed fraction. So 1.5, let me do here drafting. 1.5 is equal 1 and 1/2, which is going to be 3 over 2. So instead of 1 and 1/2, I'm going to rewrite is equal negative 15 over 14 times 1 over 15 and times 3 over 2, where 15 is gone with this 15, and our answer is going to be negative 3 over 28. So negative 3 over 28, it's going to be radian, okay? Negative 3 over 28, it's going to be radian per second. So this is our going to be our answer. Negative 3 over 28 radian per second. So the negative value indicate that the angle is decreasing as the ladder goes down, right? Slides down the wall. And that's why it is negative. So what we can say about this solution, that the angle between the ladder and the ground changing with the rate of negative 3 over 28 radian per second. Okay? Already.